Hi everyone, welcome to section 22.3 where we're going to talk about circles. Yay! Now we turn our attention away from functions to a group of equations that are mostly not functions. The group is called conic sections. What do we mean by conic sections? Well, let's watch a YouTube video that will explain it, and I know you're getting tired of my voice, so let's take a look at it.
Welcome to iLectureOnline. In this series, we're going to prepare ourselves a little bit more for calculus. So this is called the pre-calculus series. And in this series, we're going to visit the parabola, the circle, the ellipse, and the hyperbola. Now, these are what we call the conic sections. And in able to approach those in a more basic, fundamental way, we're going to learn the skills that we need so that we can survive in our calculus class ahead. So the reason why they call this conic sections is because when you have a cone like this, and then you take a sheet, and you cut the cone in various ways, you're going to come up with those exact shapes that we're going to talk about. If we cut the cone like this, with the sheet, where the sheet sticks out the top end of the cone, we end up with a parabolic shape where the sheet or the plane intersects the cone. Here, if we then put the plane flat, we have then the sheet going flat like that, and we cut the cone this way, we end up with a circle where the cone intersects or where the sheet intersects the cone. If we then do the same thing, but we angle it, and not far enough where the sheet will actually come out of the cone at the top, but we angle it like this, where it cuts through the left and the right side of the cone, then we have a circle that's then stretched into an ellipse. And finally, if we cut the cone vertically like this, so that we have a section that sticks out this way and a section that cuts this way, and those two sections are then called hyperbola. So that's how we're going to investigate the basic shapes in algebra that are defined by the parabola, the circle, the ellipse, and the hyperbola in this series. So hopefully after you see this series, you will be solid in your understanding about those four shapes in algebra.
The gentleman in the video showed us how to create a circle and a parabola, an ellipse, and a hyperbola, putting either one cone or two cones together. And so what we're going to talk about are the circles and the parabolas. And of course, you can investigate on your own about the ellipse and the hyperbola. We just don't have enough time to talk about all that. So, what's the equation of a circle? Since a circle is the set of all points, like x and y points, that are the same distance away from the radius, which is r, we can write an equation for that. It's a good thing we know about the distance formula, which again is just the Pythagorean theorem. And so we have the distance formula, which is a squared plus b squared is equal to, it would be d squared if we squared both sides. And so instead of calling it some random distance, we're going to call it the radius. And so we'd have the rest the same. Well, we know it's going to be the same distance away from the center. And we can call the center point H and K. H would be the x value and K would be the y value at the center. And so plug that in. Well, since we only have one x and one y in this equation, we can drop the subscripts. So it would be just x minus h quantity squared plus y minus k quantity squared. Okay, and then if we squared both sides, we get r squared is equal to x minus h squared plus y minus k squared. And if we just rewrite that so we have the right side on the left side and the left side on the right side, that's the equation of a circle, which once again is just a squared plus b squared is equal to c squared, the Pythagorean theorem. So, do you remember how we came up with the distance formula from the Pythagorean theorem? Can you see the Pythagorean theorem in the equation of a circle? Pretty cool, huh? So now let's do some problems that involve the equation of a circle. Number 1 says, write an equation of a circle centered at 10, 4 that passes through negative 6, 19. So here's the equation of a circle. Well, the center is 10, 4, So h is 10 and k is 4. But it doesn't tell us the radius, but it does tell us that it passes through this point, negative 619. So the distance from 10, 4 to negative 619 would be the radius. So to find the radius, that's just our distance formula, which is our Pythagorean theorem. And so we plug in 10, 4 and negative 619. So x2 minus x1, so negative 6 minus 10 is negative 16. Negative 16 squared is 256. And then the y's, 19 minus 4 is 15 squared is 225. And so add them together, r is the square root of 481. Okay, so now we know our h and our k, which is 10 and 4. So plug those in, and then we want r squared. Well, we know r is the square root of 481, but then we would square it. So the square root and squared cancels out, and we just have 481. Okay, let's go on to the next page. Okay, so let's take a look at problem 2. It says find the center and radius, then write the equation of the circle with the diameter that has endpoints -1, -8, and 9, -6. Well, if we think about this, we have a circle and then the diameter has endpoints -1, -8. So I don't know, maybe down here, -1, -8. And then 9, -6 could be here. And that's the diameter. And so that would be the center. Well, we know to write the equation of a circle, we need our h and k, which is the center. So h and k would be here. And then we also need to know our radius. Well, they don't give us either one. They just tell us the endpoints of a diameter. Well, we can find the center because we know how to find the midpoint. So, and the center would be the midpoint of the two endpoints. And so we find the average of the x values and the average of the y values. So -1 plus 9 is 8, divided by 2 is 4. And then for the y values, -8 plus -6 is what? -14, divided by 2 is -7. And so this point here would be 4, -7. Okay, so we can plug 4, -7 into our circle formula. Well, now we need to know the radius. Well, the radius is just this distance from the center to either one of these endpoints. You could pick either one. Which one did I pick? I picked this one, the 9, -6. And so we can plug it into our distance formula. So 9 minus 4 is 5, and 5 squared is 25, and -6 minus -7 would be 1, and 1 squared is 1. Plug it in, you get the square root of 26. So r is the square root of 26, so you plug that in, you'd have the square root of 26 squared, and so that would just be 26. And so there's the equation of the circle. Okay, let's stop the video here. I think it's getting a little long. So let's pause it, and then when you're ready, come on back and watch the next video.